Section 9.4, example number 5. You're supposed to simplify without a calculator each one of these expressions. And the first one to look at says that if you take the sine of an angle, then you're going to get a ratio. Now, because the angle, which is essentially created by arcsine, comes from the sine of an angle creates the root 3 over 2, then we don't need to worry about any domain restrictions. So all we need to do is ask what the angle is that has a ratio of root 3 over 2. So for the sine, that's going to be pi over 3. Therefore, the sine of pi over 3 gives us root 3 over 2. Another way to look at this is that the sine and the arcsine essentially undo each other. And because they do, you end up back where you started, which is root 3 over 2. For part B, it's the same process. The tangent and arctangent undo each other. Therefore, you end up with what you started. But in part C, you have to be a little more careful, because here the arc cosine automatically has a domain restriction. And the arc cosine is the dominant function, and this is the baby. So because the arc cosine is going to run from 0 to pi, I have to make sure that whatever this value is, that it runs between 0 and pi. Now I know that working with the cosine and arc cosine, because the two of them undo each other, then logically my answer should be where I started, which is pi over 3. The only thing you have to check is my answer going to follow within or fall within the domain restriction of 0 to pi? And if it does, then you're good to go. And by the way, the cosine of pi over 3 is 1/2, and 1/2 is going to be okay. For part D, the arcsine and sine, again arcsine dominates, so we have to honor the domain restriction. And the domain restriction for this one is going to be from negative pi over 2 to pi over 2. Correction, it's going to be from negative 1 to 1. So whatever value this is right here must fall between negative 1 and 1. Now if I figure out what the sine of 11 pi over 6 is, which is the same as the sine of negative pi over 6, then the answer of the sine of negative pi over 6 is negative 1/2. If negative 1/2 falls within my domain restriction of arcsine, and the domain restriction is negative 1 to 1, then I'll get the same answer I started with. But I'm not. This particular thing has to fall between negative 1 and 1. Therefore, I cannot use 11 pi over 6, because if I do, then I have to pass all the way through pi in order to get there. And pi is not going to be a part of my domain. Therefore, I have to instead go backwards and use negative pi over 6, because negative pi over 6 does fall between the domain restrictions that we want. Therefore, the arcsine of negative 1/2 should be negative pi over 6 instead of 11 pi over 6. When you go to example 6 for solving for x, the arcsine of something will give you pi over 2. So what we'll do is take the sine of both sides in order to eliminate the arcsine notation. The sine of the left-hand side, the sine of the right-hand side, gives us these two right here, essentially undoing each other, and you're left just with the baby, x squared minus 3. And the sine of pi over 2 is 1. Now you solve for x squared, and you get positive or negative 2. If you have a look at number 7, sketching the right triangle and evaluating, remember that when you're looking at tangent of x, we're allowed to have tangent of x run from negative pi over 2 to pi over 2. Therefore, the tangent of x is going to fall in the first or the third quadrant. They tell you that x is equal to the arc cosine of 2 over root 5. Now that's a side ratio, 2 over root 5, and it deals with cosine. So if I'll just take the triangle for cosine and place it into the appropriate quadrant, and remember that the quadrant right here is going to be the first quadrant because both these values are positive. And then I'll have 2 for my adjacent side and root 5 for my hypotenuse, and therefore using Pythagorean theorem, that leg right there will be 1. Now using that information, I can claim that the tangent of x is going to be based on this triangle, opposite over adjacent, 1/2. Therefore, the tangent of x is 1/2. For example 8, to find the cosine of y, given that the arc sine of x equals y, I want to remember that the arc sine is going to give me the ratio in order to get an answer, which is an angle. So I'm given the ratio of a triangle for sine. Therefore, I draw my arc sine triangle, and I show that x is going to be the opposite, 1, x over 1. 1 is the hypotenuse. Using the Pythagorean theorem, I can find this side right here, and when I do, it's root 1 minus x squared. So now I have the opposite, the adjacent, and the hypotenuse. Now I can figure out what the cosine of y is, and I can say that it's going to be the adjacent over the hypotenuse, or just root 1 minus x squared. For example 9, which is a key example, you can use this example to figure out what the derivative of an arc cosine, arc sine, or arc tangent function is. The way we'll do it is we're going to take the derivative of arc sine of x, and we're going to remember that another way to write y equals arc sine of x is also to write sine of y equals x. And if you recall at the beginning, they wrote down in the table that the arc sine of x equals y is the same as sine of y over x equals x. In other words, I just flip the x and y values. So we're going to rewrite the arc sine of x as sine of y equals x. And by having rewritten this equation, I can now take its derivative. So the sine of y's derivative is going to be cosine of y. But because we're taking the derivative with respect to x, we'll have to use implicit differentiation. So it's not just cosine of y, it's also the cosine of y dy dx. Taking the derivative of x with respect to x gives us 1. So now we can isolate y prime, or isolate dy dx, and I'll end up with the cosine of y coming to the other side, and I'll have 1 divided by cosine of y. So y prime, or dy dx, equals 1 over cosine of y. Now recall that we said the cosine of y is going to be the same as this value right up here, which we already found. So we're going to replace cosine of y with the square root of 1 minus x squared. So the derivative of y with respect to x is going to be 1 over root 1 minus x squared. On your next page, that's exactly what we're going to use when we try to figure out the derivative with respect to x of arc sine, of arc cosine, and arc tangent. And these three equations you want to remember. The one I remember easiest is arc cosine, and I just remember that arc cosine will have a negative 1. Arc tangent is the unique one. It's 1 over 1 plus x squared. It doesn't have a radical there. These three equations are if you use substitution, where you have a baby of u, where u is a baby or a function of x. Example 10 shows how to use each of these. For number 10, g of y, meaning that y is our dependent variable, equals arctangent of 2y minus 1. To differentiate g of y, I say g prime of y, and then I look at the baby, and I'm going to use the arctangent of u formula because I have a baby. So I take the derivative of 2y minus 1, which is 2, and that's going to go in the numerator position. And then I'm going to take 2y minus 1 and treat it as u there, so it's 1 plus u squared, or 1 plus the baby squared. For number 11, f of x equals arcsine of root x. I can rewrite that as arcsine of x to the 1/2. My baby is x to the 1/2, so I'm going to let u be the baby x to the 1/2. Take the derivative of x to the 1/2, and I'll get 1/2 x to the negative 1/2, which is going to go into the numerator position. The denominator is going to be root 1 minus u. The u value we already said was x to the 1/2, so I put it in there, and make sure you square it because the formula requires that the baby be squared right up here. So now I square x to the 1/2, and when I do, I get just x. We can clean this whole thing up, simplify it, move the 2 down into the denominator, Because x is to a negative power, I can put it down here as root x, or x to the 1/2, and then I have the rest of the radical which remains down here. You'll probably see this form as a multiple choice answer rather than this one. For h of t equals arc cosine of natural log of t, the baby is natural log of t. The derivative of natural log of t is 1 over t. Recall that the baby, in this case, using arc cosine, is going to take its derivative as a negative. Therefore, it's negative 1 over t, and then it's 1 minus the baby squared, and the baby is natural log of t. Another way to write it is negative 1. Natural log of t squared remains, but I can take this t in the denominator right here and move it into the denominator position, and becomes negative 1 over t root 1 minus baby squared. And those are your examples for 9-4. The homework tonight is to only do the odds for 9-4 and then look at the assignment sheet for review. Good luck.